Hello and welcome to another Cloud Runner demo. In today's demo, we want to access AWS Lambda from RDS. So what we will see in today's demo? First, we will take a quick look at RDS and give a quick explanation what is behind that term in the AWS universe. Then we will create an AWS Lambda function that can be called from PostgreSQL. And we will use a SAM template to do that. The AWS Lambda function is called from PostgreSQL. That means we will have a PostgreSQL table and a trigger attached to that table. What is required for this demo? First of all, an AWS account, ideally a free tier account. Then you will need access and setup of the AWS SAM command line interface. Inside AWS, you need an RDS Postgres instance, and of course, code editor, command line tool, and a database PostgreSQL client of your choice. It would be good to have some basic knowledge about using the AWS Web Console, AWS SAM, and ideally basic Python and PG/SQL knowledge. AWS RDS is a relational database service. So it provides managed instances of databases like Oracle, Microsoft SQL Server, or PostgreSQL, also others. PostgreSQL is an ideal candidate for cloud migration from Oracle because some concepts, especially the language PG/SQL, is pretty similar to Oracle's PL/SQL language. That's why PostgreSQL has become a popular choice when it's about migrating from an Oracle database. Let's take a look at our migration scenario. Usually we have an Oracle database that communicates via JDBC or OCI with an application. And when you think about the database, first you may think about relational tables, as well as stored procedures and triggers, illustrated by that lightning symbol here on the screen. And the migration is pretty straightforward. Tables translate to tables. PL/SQL code will be translated into PG/SQL code of PostgreSQL. There are also tools available to do that. And of course, also the content. Besides the database metadata, the actual data content can be migrated to the new database. But there are multiple features in Oracle that are not original database features. You know, Oracle can, for example, access the file system. It can send emails. It can communicate via HTTP, TCP. There's an advanced queuing engine built in the Oracle database, job control. And all that is used quite heavily in database-centric architectures. So what do we do with those features? A possible solution could be to call an AWS Lambda function from our RDS PostgreSQL instance. And once we have access to Lambda inside a Lambda function, we can call out to almost any component of the AWS ecosystem. So we could get to S3, SNS, SQS, and so on. At this moment, as usual, the quick warning: signing up for the AWS free tier account does not mean that no charges can occur. You can easily set up resources that are not free tier eligible, and that can lead to significant charges, especially when your account is not monitored. So please set up a billing alert in your account that will give you a warning before you have charges. Especially RDS instances can be set up, but to be in the free tier, you need to select a small instance to do that. And ideally, when your free tier year is over, stop the instance regularly. Now let's start with our hands-on demo. Before we look at the code, let us take a brief look at the involved components. There's our PostgreSQL RDS instance with a table. Then we create a simple Lambda function based on the SAM template. We also have to add an IAM policy and role to grant access from RDS to Lambda. Finally, a database table trigger will issue an event that causes a CloudWatch entry through our Lambda function. Here's our SAM template. In that template, we define two resources. The first resource is our Lambda function that we want to call from our database. It is written in Python and has the handler in the app.py file. We'll look into that later. And there is the access role, the IAM role that we have to define to enable RDS to execute our function. So we have a Lambda invoke function statement here, and because this function is actually created at runtime, we do not know its ARN, so we have this handler here to get the actual ARN back to this policy here. And another important thing is this assume role policy document. It enables the RDS service to assume that this role gives access to perform an action. If you don't have the assume role policy, you cannot assign the role to RDS. The Python Lambda handler is very simple in this case. We basically just issue a logger event here to demonstrate, okay, the function has been executed, but we also want to see what can we get back, so we get something like a return message back to our database. When we have built and deployed our SAM template, we can check in the AWS console for the created object. So we see we have our RDS function here and our RDS access role. So these two objects we've defined and they've been created, but there's one manual step we have to do. We have to get to our database and we have to add the access role. This is the one. So it's already here. You see we have this current IAM role for my RDS instance. So that's important, and we can't do that in the SAM template because that's a restriction. CloudFormation and SAM, you can only define and configure new objects that you bring into AWS. You cannot make changes to existing objects. Of course, we could create a complete RDS instance inside the template, but we assume that our database is such a central object in our ecosystem that we have it already. So we have to make this change manually. As the Lambda side is ready in our implementation, we can take care of the database side. So we have our dbeaver database tool here, and we are connected to an AWS PostgreSQL DemoDB. This is the RDS service. And the first thing we can do, we can issue a version select, and we get back PostgreSQL 12.6, which is actually important because the Lambda extension that we need is not available for all RDS PostgreSQL versions, especially not for Aurora serverless versions. Sadly, it's still not supported. Talking about the extensions with show RDS.extensions, we can get a list And we see in that list, this is our extension of interest, the AWS Lambda extension. To initialize it, we can say create extension if not exists AWS Lambda Cascade. I've done that already, so it has no effect. You need to do it at least once. So, and we have access to AWS Lambda from our PostgreSQL database. Now, how do we reach out to our Lambda function? There are two important functions involved here. The first one is AWS Commons create Lambda function ARN. So that creates a handle to the ARN of our actual function. So you see this is actually the function name here that we've created in our SAM template. And to invoke a Lambda function, we can use this, get the ARN handle, get in our function name, the region, and then we can hand something over like hello from Postgres. I'll see how that goes. So let's issue this. And okay, select's been executed, and we're getting something back here. We're getting back a status code 200. That's good. And we get back a payload that says status code okay body message something to return to RDS. So maybe we remember that's what we sent back in our Lambda handler. That's looking good already. So it seems that our function is getting executed. Let's take a look into the log. Here's our log stream. This is the recent one. And what are we getting here? We're getting a message saying event from RDS received, body hello from Postgres. So the body that we sent over from our PostgreSQL select has been received on the other side in the Lambda function. See, this is what we actually logged. So we logged pretty much the event that's coming in. Good so far. How can we take advantage of this in a real database application? Let's take a look at our Northwind schema here. We have, for example, a products table with like example products. For example, here, product ID 22, Gustav's Knäckebrot. And we have units in stock. Now let's imagine we have a trigger on that table. Actually, an update trigger reacts on each row update and will call a related function products update TRG. And products update TRG will call our Lambda function. So you see what we are doing. We're heading over the new units in stock. So let's say the units in stock change. So we will send out a message to Lambda informing the system that the units in stock have changed for a certain product ID. That's actually pretty close to what you will find in very database-centric applications, that database triggers issue events. Maybe there's a procurement system docked on to start a procurement process of new units of Knäckebrot. Let's try it out. So let's change the 200 units in stock to 100 units, which is obviously way too less to have in stock. Persist this. Now we have to look into the log. What did we get? Here's our CloudWatch log. I have to see, maybe there is a new log stream being created. Yes, let's look into this one. And you see, yes, we got it. We got the log info message, event from RDS received, body, product ID 22, that's our Knackebrot, in stock 100. So our message has been received. And of course, if you think about what we are doing here, we don't want to only issue a log message in a more real world application. We would probably call different components in our AWS ecosystem. In this demo, we had our first encounter with RDS. We have created a SAM template to call a Lambda function from out of RDS. We have created database code to call this Lambda function. And we have issued a database event that triggered this Lambda function. Well, what could be the next steps? We could use Lambda to call other AWS resources like storing or receiving data from an S3 bucket. We could do asynchronous calls or something else. Well, thank you for watching and hope to see you again soon at the Cloud Runner.